with the Argonne and Oak Ridge Leadership Class Facilities and also NERSC. So today's speaker is Ian Lee. Ian is a computer engineer working in the high-performance computing facility at the Lawrence Livermore National Laboratory in California. That facility hosts some of the largest supercomputers on the planet. And there, Ian has created a role to perform cyber assessment, penetration testing, and purple teaming duties for the facility. He has a strong background as a software developer and has a passion for the use and development of open source software practices. His motto is, leave things better than you found them. And with that, Ian, please take the stage.
Thank you, Osni. All right, you should be able to see the slides now?
Yep.
Great. So hello, everyone. My name is Ian Lee. I'm a computer engineer out here at Lawrence Livermore National Laboratory. For those of you that aren't familiar with the DOE complex as well, we sit out here in the Bay Area of California. So we're in the eastern part, just east of San Francisco, about 50 miles east. And we sit on an approximately 1 square mile patch of land. It used to be a Air Force a naval air station back in the early 40s and into the 50s before it became the site for Lawrence Livermore National Laboratory. Actually, just to the bottom left of this image, you can see the Sandia, California location as well. So Lawrence Livermore is one of 17 U.S. Department of Energy national laboratories scattered across the country. Specifically, we're a portion of the 3 labs known as the Tri-Labs, which consist of Lawrence Livermore, Sandia, and Los Alamos National Laboratories. So Los Alamos National Laboratory got its start back in the Manhattan Project during World War II, and later was sort of the counterpoint of Lawrence Livermore was created to really be a challenging force for Los Alamos. The idea was we wanted to have a counterpart to just the one national laboratory in order to push the research and development further than if there was only a single site doing work. More recently, the part you actually may have seen of Lawrence Livermore is we actually appeared in the movie Star Trek Into Darkness in 2013. So if you have seen that movie, when they're in the engineering room, which is what this picture is of, or towards the end of the movie when they're actually inside the warp core, those scenes were actually filmed here on site at Lawrence Livermore in the National Ignition Facility. Now, like any large organization, we have about 7,000 employees here at Lawrence Livermore. We end up with a lot of silos. And so what had happened over the years was various different software groups all across the laboratory were developing software. Much of it was internal, focused on physics applications or engineering applications or other computer science problems, a lot of software development here in my part of the organization, which is Livermore Computing, where the high-performance computers sit. And there wasn't always a consistent vision of how to deal with that software, how to make it available for those pieces of software and those applications that should be. Much of the work that we do does not get released to the public, but a lot of it does. We have a long history of releasing software that actually goes back into the 90s, where Lawrence Livermore has been putting out open source software to the public. Now, historically, this was tarballs put or other archive files like a zip file on a website, on an LLNL website. But occasionally, as different services became available, code moved into SVN and may have gotten hosted on SourceForge. That service is still around. Other services, as they came online, as Git was invented in the mid-2000s, and then GitHub was created. There was also Google Code, which also hosted Git repositories for a while. That service has now had code posted to it and actually now gone away. Google has stopped supporting it, and it just sits there as a read-only view of what was there. So there's been a variety of services, and there was never really a consolidated, really coordinated effort to try and put all the software together and put a common view on them. So what we have done this software that's been developed traces back over the last 60 years. So Lawrence Livermore has been involved in software development and some of the pioneering computer work for 6 decades now. This has gone up through the mainframe environments and doing 3D physics simulations. A lot of that work still continues. There's also now more and more climate modeling, more machine learning work is coming online, and a lot of big data, big science, big analytic problems happening on Lawrence Livermore systems. Today, in our history, as of this year, we've had actually 3 out of the 16 #1 systems over the last 20 years have been Lawrence Livermore systems hosted here. So we had ASCII White in the early 2000s, Blue Gene L in the mid-2000s, and then Sequoia made the list in June of 2012. Our latest system, which is Sierra, is in the process of being accepted. This is going to be I believe it's on the top 500 list as about a 75 petaflop computer. And this actually debuted in the top 500 list last month in June at number 3, shortly behind the new Systems Summit, which is at Oak Ridge National Laboratory. And I'll pause to see if there's any questions real quick. Doesn't look like there have been any, so I'll go ahead and move on. So as part of supporting these large high-performance computing systems, we've done a lot of software development. One of the biggest projects, one of the most successful projects, has been the ZFS on Linux project. And so this actually began and has kind of an interesting history. It started as it was actually started by Sun Microsystems back in the 90s to handle file systems for the Solaris operating system. And in the early 2000s, right around 2001, development started here at Lawrence Livermore to adapt that into open source software that could be used and worked on Linux operating systems. So there was a discussion early on with Sun Microsystems to see, is there any interest in them supporting that? They at the time decided they weren't interested in supporting a Linux variant of the ZFS file system. So since it was open source software, Lawrence Livermore actually took that, created a fork of that, and started development internally. It continued through the 2000s. Development continued on Solaris. It also was made available on FreeBSD. And in 2011, it was made available as the ZFS on Linux project from Lawrence Livermore out as open source software. And that was developed here at our site to support the large file systems that we have. Currently, we have, I think it's a little more than 10 file systems now that support over 100 petabytes worth of total storage. And here, we really were trying to solve the problem of no file system could really handle the limitations of existing storage solutions at the scale that we were trying to do those operations at. And so you can see in the top right, that's a graph cut out of GitHub, which is where the repository is now hosted, where development has continued at a pretty steady pace all throughout the last 10 years that it's been available as a Git repository. And I think it's kind of an interesting case. We actually, ZFS on Linux has become part of the main Ubuntu distribution as of version 16.04. So if you're running just a regular Ubuntu operating system on your home computer, your home desktop, your home laptop, you can actually install ZFS that was developed here at Lawrence Livermore on that operating system and use that as your local file system. Now, ZFS actually got onto GitHub as many other...
Hey, Ian?
Yes. Yes, Ashley.
Sorry, I was getting some interference on my end, but it went away, so keep going. I'm sorry to bug you.
Okay, no problem. So ZFS has been on GitHub for quite a while now, since 2011. I believe it first showed up on GitHub. And that actually predates a lot of the work that we did here at Lawrence Livermore to centralize and standardize where we were hosting our repositories. So as I kind of laid out earlier, up until about 2015, we actually had various repositories, and it was really up to each individual developer to figure out where was the best place to host their code, be it SourceForge, Google Code, an archive file on a website or what have you. So ZFS actually had a long history. They've done things like created a very active issue tracker and collaborator environment. It's one of the most active, most starred, so the most liked GitHub projects that Lawrence Livermore has. It's actually the #1 that Lawrence Livermore has. And it's actually, I believe, I forget the exact number, but I believe it's number 39 for all C language projects on GitHub, actually, in terms of the number of stars that it has. But you can see at any given time, there's roughly 1,000 open issues. Currently, there's about in the high 3,500 closed issues, so issues that have been taken in from the community and merged into the project. And ZFS, as one of the early adopters of GitHub and users of open source, they actually did a lot of the work that has become now more centralized, but they actually did a lot of the work on their own initially in the form of creating things like a contributing page. So they have a contributing document that you'll see if you go and make a contribution. If you open a pull request or open an issue against ZFS, you'll get a link to this contributing guide. And it has information like, how do I get started with ZFS? How do I debug ZFS? If I'm trying to build ZFS as though I'm a developer, how do I go about that and what sort of testing is involved? And this has become really helpful in a lot of open source projects and a lot of open source communities for standardizing the format of a software project, so standardizing the contributions, the look and feel, and making it more maintainable going forward. Now, this is what ZFS did really of their own volition, but it's become one of the main contributions to Lawrence Livermore's entire approach to open source software. So projects like ZFS and others like MFEM or ROSE or SPAC or some other very successful projects where they have similar things to this. We're actually looking and working actively to standardize some of these things. Now, being a national laboratory, being part of the Department of Energy, part of the U.S. government, we have some obligations. So in our license, for instance, we have text that calls out that this work was produced at Lawrence Livermore National Laboratory, that it's under contract between the Department of Energy and Lawrence Livermore National Security, which is the organization that operates the national lab for the Department of Energy. And we actually have a reference to the code release number that we have given a project as it's leaving the laboratory. So all of our open source projects, before they end up on the internet, go through a rigorous internal review process. And there, the main things that we're trying to look for are, are there any export control concerns? Is there any sort of classification or information sensitivity concerns? Or anything that might be detrimental to the laboratory, the Department of Energy, or the U.S. government. So those are three of the main categories of things we're looking for before a project becomes available as open source. And there's discussion internally, and that process is a lot of what we've worked on over the last couple of years now to try and streamline for our developers. Some of that is like the contributing guides that you've seen. Some of it is internal and really doesn't get advertised as much. In addition to just having documentation, we're actually working a lot to standardize on how to do good software engineering practices. So things like testing, continuous integration, build and test processes, not just for ZFS projects that are getting very actively used, but trying to make that a standard for our open source projects so that if any contributor or any developer comes in and they want to make use of a Lawrence Livermore open source project, that they'll have some confidence that it does what it was meant to do and it's been tested, and if they wanted to go and contribute, there's some confidence both for the developer who's contributing something and for those of us hosting the code that it passes our tests. Initially, a lot of the tests here are functional tests, unit tests of does the functionality of a piece of code continue. If a developer is introducing some change, you don't want that to break other existing functionality that another user may be depending on. And that's a large part of what continuous integration started as. Some of the things we're looking at going forward, though, are to have automated checks for things that are more stylistic or even getting into security significant things where we don't want any sort of password to get checked into a open source project or some bit of some sort of information that shouldn't have been in there, a comment that points to someplace it shouldn't, or that's just unreachable for the general internet user. And so these tests and building them up is a lot of what we've done recently to build up and standardize. So we're actually working closely with the Office of Science and Technical Information, OSTE, out of Tennessee, which is the component of the Department of Energy which actually handles the making available of all the science and technical information developed by the Department of Energy. So after we release a project, it'll actually go out and be made available at OSTE as sort of the record keeper for a given project. And I'll have a little bit more to say about that later on. So this is an example of an open source project. This was a project that started internally, and at some point it was decided that it's ready to be developed as an open source project. It went through a release process, and now it's hosted out on the internet. In this case, on GitHub is where we've standardized on hosting our code repositories. But there's other projects that are a little more split, where for a variety of reasons, perhaps performing some extra reviews or just wanting to have an extra assurance of what's actually getting publicized, there are projects that are actually developed internally which are then periodically pushed out to the internet. So it's getting back a little bit more to that archive on a website approach, but something a little more approachable where developers can still use the tools they're used to, like GitHub, to open issues or pull requests against that project. And so one such example of that is the Hyper project, which is a sparse linear systems solver. And this is a project that the primary development lives actually internally on our internal Bitbucket hosting platform, and then is periodically pushed out into GitHub. And you can see there are still issues that get opened. Pull requests are still welcomed. They just get pulled into the internal version and then become available on the next time a release is pushed out to the GitHub copy of the repository. And over time, it may be that as the comfort level increases, that we might move some of the projects, more of the projects out where the active development is happening on GitHub. But for right now, there are some projects that want to have that split. And you can see, it doesn't stop just any user from who's using this software to now actually have a channel to communicate back issues. Previously, when there was just an archive file sitting on a website, there might be a link to an email address. Hyper did have an email address where you could send an email for support tickets. But here, since we have the project available as a GitHub repository, users are able to open issues, have an actual discussion, link to the code, and do various things like that that a lot of developers have come to really rely on by the tools that GitHub provides. I'll take a second to pause there. Looks like there's still no more questions. There's still no questions, so I'll keep on moving. So another example of, so these are two open source projects that we actually currently put out. There's many other examples. You'll see in a minute there's over 400 open source projects that Lawrence Livermore produces. But we're also consumers of open source projects. And so, for instance, we have a project called ARES, which is developed here, and it actually has many dependencies as part of it. And so here you can see there's actually many components, some of which you might recognize the name of, and actually about half of them, maybe a little over half, are actually open source projects. So not only are we not only are we producing open source projects, but we're actually consuming them into our internal projects. And we contribute back to a lot of these projects as well. The Python project in particular is one that I contribute to. You can see that some of these, like Hyper and Samurai, are actually projects that we, Lawrence Livermore, produce and then turn around and consume the open source version of. And then there's other projects that we pull in as well that get developed internally. So I mentioned we have over 400 projects. A couple of years ago, we decided, what if we could put all those various projects, currently there's a couple of different organizations on GitHub that are in use, what if we could put them all together? And so what we did was actually create a software portal that did exactly that. So if you go to software.LNL.gov, you can actually see a page that will show you all of the open source projects that we currently have. You can see ZFS, as I mentioned earlier, is currently the most popular based on stars on GitHub. SPAC is currently number 2 and growing rapidly. And then there's other projects other repositories out of the ZFS on Linux project, the MFEM project. ROSE is in the top, number 7 there. and the list goes down from there. And you can actually filter if you have a keyword that you're interested in, let's say Python, you can put that into the filter bar at the top and find projects that if you wanted to come and contribute to a Lawrence Livermore project, you could. Now, like any good open source project, any open source minded person, this website here is actually generated using Jekyll and GitHub pages. We actually host the site on our own servers, but the content of this, the actual source code for this site is available as a GitHub pages site. So it itself is one of the LLNL GitHub organizations. And one of the nice things there is we were actually able to model it after other GitHub pages sites. So this particular format and this particular view of this information is based on the Microsoft, Netflix, Twitter, and various other GitHub pages examples that were in GitHub's showcase for GitHub pages sites. And so we were actually able to use those to pull in content and pull in different ideas and see how other projects have worked with this. We've also added a lot of information. So if you see in the top right, there's an Explore link you can click on. If you click on that, you'll end up with several graphs that try and dive into the software repository data. So for instance, we have our open source presence graph. So this is trying to recognize for the projects that we have on GitHub currently, again, about 450 or so, how many of those, or rather, for each of those, when was the first commit of that project, and when did it first show up on GitHub? So you can see, tracking back that green line, that actually shortly after GitHub was founded in 2008 is when we had our first projects moving onto GitHub, and there's projects that have been there ever since. Furthermore, we have projects that are currently hosted on GitHub.com that began their life as development projects back in as early as 1994 is that dot all the way to the far left. Long before GitHub was founded or even Git was created in 2005. And so you can see in a lot of these cases you'll have seen, if you look at the history, that a project was developed maybe just as files on disk originally. Then it moved into maybe CVS, then maybe it got migrated forward to SVN, and then later got migrated into a Git repository that now lives on GitHub. But by combining all these projects into one place, or at least starting to organize them in a common platform into a common organization, we're able to, in the future, if GitHub is ever replaced by something else, we'll be able to pick up these projects and move them to a new platform in a much more easier fashion than having to go hunt around the internet for them all. Additionally, you can see that since we've begun, work in earnest to develop our software portal, develop our open source practices, and really drive that conversation both externally with our collaborators as well as internally with our developers and our senior management, you can see that over the last 8 years or so, and in particular over the last 3 or 4 years, we've seen a steady increase in the rate of new projects going out on GitHub. And additionally, more and more projects are getting released as open source earlier in their lifetimes. So projects are staying internally developed for much shorter periods of time than they once were. And a lot of that has to do with these platforms and these resources that are available. So not only do we have a volume of projects, but we actually also have many organization members. So the LLNL, github.com/LLNL organization is our primary GitHub organization. There are several others that exist for either historical or a few other reasons, such as the ZFS on Linux project, the ZFS on Linux organization, the MFEM organization, the SPAC organization, and so forth. We pull all those together for the software portal, but if we look at those different repositories and our organization, we actually have about 180 organization members in our LLNL organization. And so these are LLNL employees who are members of our GitHub organization. Of them, 53% of those individuals, of those users in our organization, contribute out to some non-LLNL owned organization, open source project. So we're actually pulling a lot of this data from the GitHub APIs to generate these graphs and to generate these views on this exploration page. And you can dive into them and see how they work through the source code for that llnl.github.io repository in our GitHub organization. So 53% of our organization members contribute externally. Additionally, of the 432 at the time of this screenshot GitHub organizations we had, 75% of them have an external contributor. So it's not, it's the minority of projects that are only developed by LLNL employees. The vast majority of them are developed by external, or contributed to by external folks, external developers like yourselves coming off of the internet and being interested in giving back, fixing a bug. Sometimes it's as big as some new physics algorithm to a particular application. Sometimes it can be as little as fixing a typo in a README. Both of those contributions are valuable to any open source project. You can see I mentioned SPAC and ZFS as being two very active projects, but in reality we have many active projects across our GitHub organizations. And so this is a scatter plot. You can mouse over these dots in the website to see which projects they represent. But the majority of projects are actually very active. They get their pull requests and issues that get opened, get merged and closed into the project. So we actually have put a lot of effort into trying to move those projects forward and figure out what are the projects that the communities are very active in addition to what are the ones that LNL is very interested in maintaining and pushing forward. And so graphs like this and some other graphs that we have ideas for are ways of looking at the data available from GitHub's API and seeing what projects are most popular. I mentioned that we have had, I think, a great amount of success over the past few years in getting more visibility on our open source work, on our open source projects. In January of this year, or February of this year, I believe was published, we actually had a featured article in the Science and Technology Review publication that Lawrence Livermore National Laboratory puts out. And this actually looked specifically at open source software and how that software is put out. It highlighted a few projects, some of which I've mentioned already, as particular callouts and particularly diving into how those projects work and accept contributions into themselves. But as part of that, there was actually a commentary by some Lawrence Livermore senior management really pushing forward and really standing up and saying that open source is an important part of what Lawrence Livermore does. And so in particular, we had a commentary piece written on the article by Bruce Hendrickson, who's the Associate Director for the Computation Directorate here at Lawrence Livermore, who pointed to the large collection of software as a precious asset that benefits Lawrence Livermore and the public at large. And this is a really strong, this was the opening statement for that commentary piece, and this is a full-page commentary piece about why open source software, why collaborative development is important to Lawrence Livermore and efforts that are larger than that. So being that this is an ECP ideas, best practices webinar, this next part might not come as much of a surprise, but the Exascale Computing Project across DOE is one example of a project where now going forward, there's been even more emphasis on this. And so ECP has this article here that points out that virtually all of the software stack being developed is composed of open source software. And this is really making a strong stance on the value of open source to the Department of Energy, whether that's trying to share an application from one laboratory to another, or from a laboratory to a vendor that you're working with on some exascale computing system. These are becoming, starting to actually become requirements in upcoming contracts for new systems that are being brought online. So there's a lot of work to really emphasize and push open source software. The Department of Energy is obviously a forerunner in a lot of the open source work. We have a fairly sizable chunk of the projects that are available from U.S. government organizations. Actually, DOE is a large percentage of that pie. I believe it's about 10% of all open source projects across the entire federal government. Might actually be higher than that now. And a lot of this has come up in the last few years when in 2016, the U.S. government came out with the federal source code policy. And so this was a policy that... I'm sorry?
Hey, Ian, it was
Hello? So I think that was trying to be a pointer to a question that I see in the Google sheet, so I'll try and address that right now. So the question is, since moving ZFS to GitHub, what portion of development comes from GitHub users at large, and what portion other DOE labs versus the LLNL manpower? So that's a good question. A lot of the development is maintained and centralized here at Lawrence Livermore, but there are many contributions that come from externally. So if you go into the ZFS on Linux GitHub project, and I can put a link to this in the GitHub, in the Google sheet later. But if you go in there, you can actually see a graph of the contributions from various different people over time. And so you can actually see who actually is contributing the most to that project. Now you'll see the #1 contributor is a Livermore developer by the name of Brian Bellendorf. He is the lead developer for ZFS on Linux, and he's the main one that pulls in pull requests from the outside of Lawrence Livermore. But if you actually look through some of the other contributors there, you'll be able to see who all else is contributing to the project and where they're coming from. So I can address that question a little more in the Google Doc and provide the links there afterwards. So moving back to the federal source code policy here, the federal source code policy came out in 2016. You can read about it at sourcecode.cio.gov is where the actual source lives. And the policy came out with two main prongs, if you will. The first one was to push the government into making custom-developed code or custom-procured code available for government-wide reuse. So it started by making the argument that across the federal government, there's actually a lot of custom-developed code to solve an application or to solve a use case that the government as a whole is having to procure multiple different times. So for instance, if you're building some sort of application that handles some particular use of data, maybe some sort of relational application, then if you're in I'm just going to pick agencies here, if you're in the Department of Transportation, you might go out and get that piece of code developed for you for your internal use case, for your internal policies and so forth by a company. And there's not an easy way to make that available to a different organization, let's say the Department of Energy. And so the policy was really to help move the government towards requiring that as part of contracts that they would put out, where if the government procures or develops themselves a piece of software, they should, in general, make that available as to other government agencies that would want to use that software. Now, there's a lot of provisions for classified code or sensitive code or proprietary information that comes from some vendor, but in general, at the very least, there was to be an inventorying of all the code. So at the very least, if nothing else, agencies would know what other agencies are procuring the same or similar software. Going further than that, the policy set up a pilot program that required federal agencies, when commissioning new custom software or developing new custom developed software, to make that available as open source. So they set a mark of 20% of the software that's produced by an agency should be made available as open source going forward from the date of that policy. Now, this policy actually is a bit interesting in that it itself started its life as a GitHub repository. So you can follow the links if you go to the sourcecode.cio.gov site, but that site is actually generated and the source code for that website is off of github.com. And when this policy came out, it came out as many policies do, in a draft phase, and there was a request for comments period. I believe at the time it was hosted off the White House GitHub organization. And this was actually one of the most commented on policies the White House had ever put out for comment. There were dozens and dozens of comments on the policy and how to interpret it, how to finesse it. And many of those changes were incorporated back into the policy before it was finalized several months after the comment period had ended. So the policy is one part of this code, this effort that the federal government is doing, but the other side of that is actually making available that inventory that I alluded to. And so code.gov is a website that is very similar to the LLNL software portal that I mentioned earlier. And this is a site where you can go and search across all these thousands of projects that are getting inventoried and are oftentimes available as open source software projects. So I believe the last time I looked, Department of Energy has about 800 projects, and across the entire code.gov site, I believe the last time I looked was about 4,400 websites. So there's about 20% of the repositories are coming from the Department of Energy out of the 25 agencies that are part of code.gov. Now, there must have been something in the air in late 2015, early 2016, because our Lawrence Livermore software portal was getting stood up. The code.gov and federal source code policy was early 2016. But around the same time, actually, the Department of Energy, OSTI, who I mentioned earlier, were in development of a similar application to provide an inventory and a way to search through the Department of Energy open source projects and released software projects. So here, what happens is, as I mentioned, when a developer at Lawrence Livermore releases or goes through the release process to open source a particular software application, as one of the deliverables out of that process, the application and some of the metadata about that application, like the developers, which laboratory it came from, and some other information, is provided to OSTI, and they actually make it available and searchable on their new site, DOECode. This went into beta alpha in, I believe it was August of last year, and then has been in beta since about November. So it's still a little early, but this is another example where the development for this site and the back end that supports it is all available on GitHub itself. And so if you go to github.com/DOECode, you can find all the source code for this inventory. Not obviously the metadata or the data itself, but how the data is all structured, how it's presented, how it's searched. And now OSTI here is actually providing some extra value to Department of Energy developers, where not just are they taking and housing a copy of the code and the metadata for the repositories that go out, but they actually do things like create digital object identifiers for the projects that are uploaded to the site here. And so this has become more and more important as new software projects are created. A lot of them are either needing or wanting to have a digital object identifier, particularly in the scientific publication space where reproducibility is becoming more and more important, where if you write a publication, you actually want to be able to point that publication back to, this was the particular version of the application I used, or the particular application and potentially the particular version of the application that I used, and additionally pointing back to things like the data that was used as input for that publication. So these are becoming increasingly important in a lot of scientific publication arenas. So that's what sort of the three layers of Lawrence Livermore, Department of Energy, and the U.S. government are doing to really try and push forward some of this inventorying and bring more visibility around how each of those layers produce and use open source software. But actually GitHub itself is very active and very interested in this problem as well. And so for those of you that aren't aware, they actually support the government.github.com government community or user group. And here you can actually go and see many, many agencies and organizations and so forth that are affiliated with governments from all over the world, not just in the US, but the UK, in Canada, in all over the world. And you can see what sort of open source projects are being made available from each of those organizations. If you actually dive into the project there, into the peer group, which anyone with a government email address can join from anywhere in the world. So .gov and .mil are two obvious examples, but there's many other email addresses that can get you into that government community. If you dive into the data, what you'll find is there's actually, according to this peer group, there are 252 organizations on GitHub that are associated with the U.S. government, out of several more hundred that are associated with other governments as well. And so just as an overview of them, you know, they span all various different parts of the federal government and other organizations. So obviously, many of the national laboratories are up there. I think almost all of them are at this point represented on GitHub with their own organizations. There's also organizations like I mentioned, the White House has a GitHub organization. NASA has a GitHub organization. They have what I think is still one of the most intriguing open source projects that I've come across, which is actually the source code for the Apollo 11 flight controller that you can actually find and look at on GitHub. But beyond even just those organizations, there's others that you wouldn't even necessarily expect that have found open source to be the way that they want and need to do their development. And so, for instance, the National Geospatial Intelligence Agency, the National Security Agency, and U.S. Department of Homeland Security all have GitHub organizations and have their own contributing guides and their own documentation. So while we might not yet have a full Department of Energy comprehensive how to handle open source, you know, all how to contribute to it, how to license it, how to answer all these questions, various other organizations do have those answers. And so as we've built up our policies, we're actually working on combining them all together and trying to learn from each other's experiences. And so with that, I'd like to say thank you. We're very active. We do have the @LNL_open source Twitter account where we talk about various talks that we're doing or presentations that are going on. And a lot of this work is ongoing. Many of these, you know, there's 400 and close to 450 open source projects. If you're interested in joining contributing to one of these projects, many of them are very welcoming of contributions, and we'd love to have you. If you have any questions, feel free to send me an email anytime. And with that, I'll turn it over to Ashley and Osni, and I see we have some questions coming in on the Google Doc.
Yeah, Ian, there are definitely 2 questions there, and I encourage anyone else at this time to add others as well.
Yeah, let's see. So I talked a little bit about the ZFS on GitHub. Like I said, I'll go in and add more information about or more links to that shortly after the call. What was involved in obtaining pre-GitHub history of projects? So that's an interesting one. There's a couple of different scenarios. One was we had projects that were just being developed and periodically would get tarred up or archived up into version 1, version 2, version 3, and that was really all the history that there was. The files just sat on a hard drive somewhere and periodically got tarred up into these archives. Oftentimes those archives then got published to places like the Computation website or other LNL organization websites. And so in those cases, what we did was actually to take those archive files and create a new Git repository out of them. So we actually untarred the archive from version 1, created a Git commit out of that, did the same thing with the version 2, created that as the next commit, and actually created a Git history out of those that we then pushed to GitHub. Other projects are a slightly different scenario. They may have started as some other version control system. Actually, a lot of the projects that we dealt with came from SVN. And so there was an SVN history, so there was some version control history for a project. And there's actually many blog articles where you can see kind of how to go through the process of converting from an SVN repository and migrating all that history and all the changes into a Git history. And I can provide a link to that if anyone's having that particular problem. But those are two of the main scenarios that we had. Either there was version control and we had to migrate it into Git and then publish it on GitHub, or there was no version control at all and we had to sort of make that. Sometimes, occasionally, we made the decision to just take the current version of the code, call that good enough, and just start a new Git repository there. That's sort of the third special case. So question, what kind of security background checks are required for LNL collaborators? So I'm assuming this is collaborators or contributors to an LNL open source project. In that case, there is no security background check. What we do is external collaborators are typically not given write access to a repository. If they are, there's some sort of existing collaboration arrangement, most typically with university collaborators, where they might over time be given write access to a repository. But in general, only LNL employees have commit access to LNL GitHub projects. There's a few special cases for various reasons. And so what that means is that any external collaborator, let's say just some random person from somewhere on the internet, when they contribute their code, they're actually going to submit a pull request into one of the GitHub organizations or one of the GitHub projects. And that actually gives a chance to not care so much about who's doing the contributing, but instead to look more at what is being contributed. And so an LNL employee will have the opportunity to review the code before it actually becomes part of the open source project. There is no automatic merging of pull requests into LNL managed open source projects. And that's important, especially as some of our open source projects get pulled internally and we care about what is actually happening in those projects and we don't want some malicious bit of code coming into the project. The next question was, what is your relationship with the project teams at LNL? How much do they need to be persuaded? How much are they leading the change? Sorry, how much are they leading the charge? I imagine it varies by team. To what extent are there official LNL policies that must be followed versus voluntary? So that's a good question. So we're very involved with many of the projects. Before ECP put sort of the public face on some of our open source projects and developing practices around that, there were efforts internally to standardize some of the software engineering policies. And so that led us to things like, particularly in some of our bigger programmatic codes, there was a standardization internally among the teams on things like hosting your code in version control. That version control should be Git because that's what all our institutional services are using, and that's what we've standardized on as an organization. You should have some sort of documentation that is available for that project. You should have continuous integration. And so actually they led sort of as a coordinated effort internally. A lot of the project teams, a lot of the bigger programmatic code teams developed a lot of these practices that really were just now taking what was already being done internally and pushing them to outside and making them sort of the standard across the various open source projects. So that starts leading into the last part of that question there, where those are our internal programmatic teams. Then we had projects like CFS that developed their own policies that they were going to follow. And we're trying to be fairly flexible. I don't believe there's a great one-size-fits-all approach for all projects. Not all software projects are created equal. Not all of them require the same amount of rigor. And so what we're trying to do is really standardize on what are the core pieces of a software project. What are the core things we want to care about? And the ones that I just mentioned, version control, continuous integration, documentation, are a lot of the ones we've standardized on earlier. Contributing guidelines is another one that we're working on. And to the extent possible, while right now individual projects have really come to a lot of those things on their own, we've been working with various different projects to create a standard for how to do that. So as we are starting to standardize on what does it mean to contribute to a Lawrence Livermore project, we're actually pulling that information together on GitHub in the LNL organization. There is a repository that I'll provide a link to that is open source guidelines. And so there is a repository we're actually starting to document and discuss what it means to contribute to a project and how to handle some of these policy things. For the most part, as I mentioned, it's voluntary, at least at the moment. There's certain things that will be thou shalt do. And some of that we're actually going to take on doing sort of institutionally, if you will, for those projects. So one of the benefits of having at least the majority of the open source projects in one GitHub organization, the LNL organization itself, I think has close to 200 of the 450 projects just in it. By having those all in one place, myself and the other GitHub admins can actually go and fix up and tweak any of the things that are needed. So for instance, standardizing on a markdown formatted README file, that way GitHub renders it properly. Making sure that we have our code release number that I showed the link to, or I showed the snippet of earlier, on that README so that it's front and center for anyone that wants to use it. These are some of the main pieces that we've started to do there. That open source, the open source guidelines repository that I mentioned, there's actually some work to, some discussion that's begun this year to make that not just the Lawrence Livermore repository and maintain it at that level, but instead to actually promote it up to the OSTI level. So there's some discussion around should that become, to the extent possible, to the extent that it's universal across DOE, can we have those guidelines be at maybe hosted in the DOE Code GitHub organization. And this is something that various other federal agencies have done as well. So 18F and GSA, which are, well, 18F is a child organization of GSA. They actually have a best practices and or an open source policies repository where they do something very similar. And we're really just trying to follow that model that a lot of the other government agencies are starting to do. And then it looks like the last question at the moment is, what are Ian's key 2 or 3 biggest advice guidance to other labs moving in these directions? So I don't know if there's a particular 2, but just to list a couple of them, I think starting small and figuring out where the successes are is really important. One of the things that I really like about open source development, what moves me to it as just a concept, is this idea that you don't always have to have big monolithic changes. Instead, you can start with wherever you're at and make small improvements. Oftentimes there's a leaning towards having these big monolithic changes change everything all at once. And I think those often take a long time, and they cause a lot of stress, both for people trying to use the process and people trying to monitor the process. So instead, making small changes and doing more agile development for those that are software developers, doing more agile development where you're taking incremental steps and incremental improvements, I think is made it a lot easier for us to gain adoption, gain traction where we can build on smaller successes. The other thing kind of building off of that is I would say make sure you get clear in terms of the communication. So as we've been working on a lot of these policy changes, I myself and various other people here at the lab have done many talks internally and hosted many brown bags and other sorts of discussions to figure out from developers, from management, from reviewers of what are the pain points, where are the issues, and to try and put some of there's never enough resources to go around in terms of working on all the projects or all the problems. So focusing on more achievable projects and starting to build that success has really helped. So for instance, one of the things where we started with this was, okay, we've been, as a laboratory, not just Livermore Computing, but all of Lawrence Livermore has been releasing open source software for 20 years now. Where are all those projects? Can we actually find them? We had some records for where those projects had lived, but sometimes a developer had put something out in one place and then later migrated it to another place. One example might be I put it on SourceForge initially, and then I moved it to GitHub, but that record never necessarily got updated. So one of the first things we did was just trying to go find all of the GitHub projects, all of the open source projects all across the internet and trying to pull them together into one place. And that's how we ended up spiking rather quickly early on in terms of the number of projects that were added to GitHub. They moved, sometimes they were just, okay, well, it was on Google Code, now we're going to push it to GitHub. Very minimal effort, but it starts to bring that effort and bring that mind share to a common place. From there, we ended up working on things like trying to standardize how the READMEs look. So if a developer comes across one Lawrence Livermore project and then goes to another Lawrence Livermore open source project, they'll feel some consistency. There'll be some context in terms of how things are structured. And then we've just kept working with developers as new projects are moving out and getting released as open source software. We've pushed those out and incorporated in any of the issues and any of the sort of lingering issues into our iterative process of improving as we went forward. So I guess that's kind of the one biggest piece of advice is start small and just keep building at it, keep at it. I think both internally, the developers at the national labs, and really across the entire federal government, if you talk to a lot of the software developers, this is the direction they want to move. And what we need to do is work on making it easier for that to happen and making sure that whatever concerns we have about scanning, reviewing, making sure that things are recorded in the right way, that we build processes around trying to automate that as much as possible and trying to move it away from being a manual process. But if you talk to a lot of your developers, I suspect you'll find that A, they want to use open source software, and B, they want to be able to make that open source software available. One of the analogies that I've heard for a lot of software developers, so software engineers, is a GitHub profile. So for instance, if you look at my GitHub profile, you see all the LLNL organizations I contribute to and all the other open source projects I contribute to. That becomes what for sort of a more traditional researcher writing papers is their CV, right? If you're making publications, you put them on your CV as I produce these publications. If you're a software developer in 2018, most often that is, I'm a software developer, I've contributed to these projects. And that's been really helpful both externally for bringing people in, where we can actually see real examples of their software development practices, but then also for motivating people internally that there's visibility of what they're doing. It doesn't just sit internally at the laboratory, only seen by the people in here. So with that, I'll pause and see if there are any other questions. I think that's it for the Google Doc. Ashley or Osni, if you had any other questions.
Nope, that's all that's in WebEx and the Google Doc. Thank you for answering all of those, Ian.
Sure.
So thank you, Ian. Yes, I would like to thank everybody for participating. And with that, I also would like to announce the next webinar in the series, which is going to be in about 3 weeks. And the speaker will be from the Software Sustainability Institute, Neil Chu Hong. We'll talk about software sustainability, lessons learned from different disciplines. Thank you all.